Alright, welcome back, and let's continue the discussion for our applications of integration. And let's start by having the applications of integration 2, which is work. So when we say work, so apparently I think you already know what the definition of work is, but in a general sense, work is when you have a force and then you move this force on a certain point A to point B, then the product of these two variables will give you work. So it's like the force times distance, and that's the general concept of having work. What happens when this work is, let's say, we need to determine the certain work of a certain material, knowing that it has a variable force. So that's what we'll be dealing with in these discussions. And for A, we have the Hooke's law, or work done by a variable force. So under that would be the Hooke's law. And remember, Hooke's law simply gives us something like the relationship between force and the displacement of this certain, let's say, certain spring or material. So this displacement multiplied by the the spring constant, so we could get the force of that certain material that is being exerted or being compressed or being stretched. So by definition, the formula for Hooke's law is simply, for the force of using Hooke's law, would be F is equal to KD, and remember, K is the spring's constant. Now there's another force which is of course existing in the natural setting of our Earth, and that's the Newton's law of universal gravitation. So if you remember this is actually the product of two masses divided by the square of the distance separating these two masses, and then you multiply this by the universal gravitation constant, which is actually the capital G. So do not confuse this with your small g, that is the acceleration due to gravity. So we're talking about this gravitational constant, that's the capital G, and that is equivalent to 6.67 times 10 to the negative 11. The unit is in SI unit, cubic meter per kilogram second squared. So I think in your Casio calculator, that's constant number 39. So that is if you press something like shift 7, that's constant, and then constant number would be 39, you'd be getting the universal constant up to 5 decimal places. Okay, and you can use that. Now how about the last one? So this last one is actually something like the same Newton's law of gravitational, the Newton's law of universal gravitation, in a sense that we apply this kind of formula to charges. Okay, and the Coulomb's law states that if you have two charges, so the product of these two charges divided by the square of the distance between them, and you multiply this by the Coulomb's constant, that's 9 times 10 to the 9 Newton meters squared per second squared. So you will be able to get the force that is existing between these two bodies, the two charges. So I don't think there is this value in your calculator, but let me just check.
A few moments later.
So I don't think we have it on our calculator in Casio. So let's just remember the value for our Coulomb's constant, that's 9 times 10 to the 9 Newton meters squared per Coulomb squared. Okay, so I think we can now proceed with the problem solving. That's just the concept of your forces, and typically we just have to determine our F and then just relate it to the general formula for work, that's the integral from point A to point B, f of x dx. So that's just the formula in all of these three types of force that we might be encountering. So for the first one, we have a variable force of the function f of x equal to x squared minus x ln of 3x in newtons. So typically that's the unit of force, is traced through a straight path from x is equal to 3 and x is equal to 8 meters. So determine the work done in joules. So if you want to solve for this, remember, you could just think about the work being the integral from point A to point B, f of x dx. So if you're given by the variable force, that is this f of x, so you can just simply substitute that equation. So this gives you what is your lower limit. Lower limit is the starting point of your where the first starts, so that's 3, and then it ends up with 8 units, so parang meters yan. And then we have x squared, just copy this value, equation, x squared minus x ln of 3x dx. Okay, And then you can perform all the methods you've already learned from your previous discussion. So I think we can use power rule here, and this one I think we will be using integration by parts. So I will not be showing you how to like do it again kasi napag-aralan na natin yan. So I hope na you could apply that, and I'll just give you the answer to this. Basta I just want to show you that this is just f of x times dx. Okay, so this gives me 83.6065, okay, joules, and that is our answer for this very basic problem. So you don't have to worry about the units here. Remember, if you have the unit of force being in newtons, and then you do have the limits of integration in terms of meter, so you'll be getting newton meter for the force that is equal to joule. So 1 newton meter is equal to like 1 joule. Okay, so that's how it goes for the first problem, and that is very easy because you're given by the variable force already, so hindi mo na kailangan mag like generate the equation. How about for number 2? So let's try solving this number 2, and probably we could understand it better than with this example. So a pail of water is being lifted using a pulley of 30 feet length by a chemical engineering student. So he is 25 feet from the pail when it is on the ground. The empty pail weighs 10-pound force, and it required 200 pounds of water to fill the pail to its rim. During its ascent, the water overflows. It is estimated that for every 1 foot rise, 5 pounds of water drop off from the pail. How much work is necessary to completely raise the pail to the top of the pulley? So with this kind of problem, we really have to illustrate this kasi it really gets difficult when we don't understand it, especially in yung visualization itong problem. So let's have it here. Well, technically it's just a student raising a pail of water. So if you have a pulley right here, and then of course meron ditong parang line lang here. So just to make this parang straight line. Okay, and then of course meron ditong pail of water. So yan. And of course, it is completely filled up to its rim. So yun daw yung definition. So parang ito, filled yan with water. Okay? And of course, there are initial conditions na binigay pa sa atin, pero let's just stick with this muna. And then of course, kung hinihila to, so you could imagine here, may string pa dyan, and this is probably where the student stands. So parang ganyan siya. Okay. So basically, that's how it looks like. And we can label all these parts. Sabi kasi sa problem natin, 30 feet yung length nung ating pulley. So that is the parang the the vertical part of this pulley, and of course this parang diagonal part that is in combination equal to 30 feet length. So itong layo nung student when the pail's on the ground, that's 25 feet. So we could of course give the value for this distance, that's 25 feet. Okay? And then sabi dito, if the pail is empty, that is 10-pound force. So basically, the weight of your let's use na lang siguro force. Ano magandang designation ito? Probably let's just use the sige, weight. The weight of the pail is equal to 10-pound force. So remember, in English units, when you have pounds, let's say I weigh let's say 100 pounds. So that is also the force that you're exerting. You're exerting 10-pound force. So it's just multiplied by 1. So yun lang yung parang concept. Kasi remember, if you have SI units, diba? Well, let's say when I weigh 50 kilograms, I have to multiply that to 9.81 to get the weight that I'm actually exerting. So technically, you don't have to do that in English units kasi the conversion factor is just 1. So the weight of the pail is 10-pound force, and then it required 200 pounds of water to fill the pail of its rim. So technically, the weight of the water that's inside of it is actually 200 pounds or 200-pound force. That's just the same thing. So during its ascent, sabi nga ulit dito, if the pail is rising, the 5 pounds of water is being dropped off from every foot rise. So we could just imagine this parang part of the loss. So we could just W have this weight loss, or the force that is being lost. That is just the 5 pounds for every foot rise. So you could just imagine the 5 pounds of water per foot, and then you have to multiply this by the certain distance that it travels. So let's just assume that we're using x here to represent the distance that is being traveled from this point going to the upper portion of this pulley. So this is x. This is typically the distance from this point of the pulley going to from this lower ground going to that upper part of the pulley. So yun yung ating maging x now. And of course, yung weight loss would be 5 per feet multiplied by x. Okay, so from this, what could be our equation? So remember, if we want to deal with the work that is being exerted by this person, we could just think about the force that is being used to move the pail from the ground going to this upper portion of the pulley. So if we'd be thinking about it, then we could just start it by 0 at this point. That's the ground level. But we have to remember that we need to compute for the value of this height, and we really don't have it yet. So what we can do here is just to use the concept here of your Pythagorean theorem. Remember, it says here that the total distance, the total length of the pulley is 30 feet. So we could just imagine this, the length of the pulley being equal to 30 feet. So therefore, we could use that concept. So if you have, let's say, 25 squared, I'm using the Pythagorean theorem, plus x squared, that is actually equal to this the hypotenuse here, and this hypotenuse is actually 30 minus this x, because that's the total length of the pulley minus this x distance from the pail. So you could just imagine this concept of Pythagorean theorem. But remember, hindi na natin kina-consider itong point dito sa pail kung di man ito nagtama actually dito, but let's just assume na negligible na yung part dito ng pail na naka-connect dun sa inyong parang handle. Okay, so from this, the value of x would be equal to 4.583 repeating. So this is the value of your x. So you will be moving from 0 point going to 4.583 feet upward. So actually mababa lang talaga siya, no? Parang imagine niyo yung yung bata to naghihila na to. So technically baka bata lang yan, kinder ganon. Kasi 4.583 feet lang yun, parang sobrang baba lang nun eh. But then, that's just a theoretical problem. So, wala tayong doon. Kaso kasi 200 pounds, mabigat din yung 200 pounds sa tubig. So anyway, let's continue this. So, if you want to determine the work, we're just concerned with the vertical distance from this 0 point going upward. So, that's the work. The integral from, ano ba yung lower limit, that's 0. And then, ano ba yung upper, that's 4.583. Repeating. Okay, and then what is the variable force? So remember, the force that is being lifted here is actually just the sum of the weight of the pail, that's 10, okay, and then you add 200 pounds because that's originally the amount of what you have to be you have to lift. But remember, as we increase our distance from the 0 point going upwards, there is this loss, and this loss is dependent heavily on the distance from the ground going upwards. So that's just minus 5x, okay, and then you incorporate this dx. So this is actually your variable force, and this 100 plus 200, 10 plus 200, that's actually the fixed force, ganon. So we're concerned with all the force that we need. So with this, the value of your work would be equal to 909.9826. So this is in terms of pound force feet. So let's check if this is the unit in your okay, so this is the unit in your module. So remember, you have to be consistent with the units, especially when you're dealing with English units. Kasi what if one is given in terms of newtons and the other one is in feet? So I would suggest that you use SI system if there's a combination of the English and the metric system. But of course, when you're dealing with all of the variables in terms of English units, you have to make sure na your answer is in terms of English units. Kasi that is a lot easier than you converting all of this in terms of newtons. Mamali pa kayo dyan as you solve the problem. Okay, so that's just how easy this problem 2 is. So I think we can now proceed with number 3. So for number 3, oh, sorry, since number 3 will be using the same problem, let's just leave it unerased. Ano bang word? Unerased. So if no water is being spilled during this ascent, how much additional work would have this student needed? So the question is additional work. So remember, if it's additional work, then you're actually considering still the original work that you have. That's 900, 10 plus 200. So what if we don't have any amount of water being spilled? So that's just like a constant force, no? So you have to make sure na you're having this integral from 0 to 4.583, and then you just have 10 plus 200, okay, dx, because you don't have any like amount that is being spilled as you move from this point up to this point, and this will give you an answer that is equal to 962.5 pound force per feet. And remember, this is the something like the total work that you have when you don't have any amount that is being spilled. So para lang siyang nagbuhat ka lang ng 210 pound force na pail from point A to point B. So it's like parang ganito nga lang yun eh. Work is equal to force times distance. So it's like 200 plus 10 kasi yung combined mass or combined force nila, then you multiply by the distance, that's 4.583. So this should give you the same result as this 962.5, but then again we have to employ yung ating integration procedure. So that is the total work when you don't have any spill na nangyayari during ascent. So technically you could just compare, mas mataas tong work 2. But if we're concerned with the additional work that we have to exert based on the original parang situation na nag-i-spill, so you just have to subtract W2 minus W1, and this gives you the something like the change in the work that you need. So that is simply equal to 52.5174. That's pound force feet. Okay, so that is your additional work that you need. So remember, we computed for the additional work because that's what is asked in this problem, no? Kasi kung work lang din naman na walang spill, that's 962.5, but since it's additional work, then we have to subtract that from the original value. Okay, so I think that's all for this pulley. So let's move forward now for the next one, which is something like filling problems ito. I mean, we have to fill a certain container. So a conical vessel 6 feet across and 8 feet deep is being filled with water until it reaches a height of 2 feet below the top. Approximate the work in British thermal unit needed to carry on this process, assuming a circular disc perpendicular to the axis is moving from the bottom to the required height in British thermal unit. Required height as 1 British thermal unit is 778.169 feet pound force. So that's our conversion factor. So the concept here is to draw this figure for easier understanding. Now for every problem wherein we have to like fill something, pwede natin siyang i-draw in the Cartesian coordinate system for easier understanding. So in this case, let's try using a Cartesian coordinate system, and that could probably help us in understanding the concept behind this one. So imagine this is your 6 feet, though not to scale, and then let's have siguro itong this part here would be your mga lateral side niya, slant height pala. Okay, so technically this is the parang front view of your conical vessel, and we can just label this as 6 feet across. Okay, so it's like parang 1, 2, dito tayo propose. So 1, 2, 3 units here, para 3 units sa kabila, symmetry lang, or symmetric lang. And then, we can have here as, parang ito is 8 units. So, medyo ano pa pala tayo, medyo hindi tayo sakto dun sa bilang. Pero, gawa natin ang paraan. Okay, so yun. This is 8 units, or 8 feet. So, parang ginawa natin siya in terms of Cartesian coordinate system. This is your 0, and this is your positive side, and this is the negative. Okay, so that is how we do it in the Cartesian coordinate system. And the question is, ano ba yung work done when we try to fill this certain conical vessel, diba? So that's just water being filled here. Okay, so remember, the work is given by the general expression, that's the integral from a to b f of x dx, and that's just of no question, that's our general formula. But how do we determine the force in this case? That's we're given with a certain conical vessel that's being filled with water. So remember, in your, could be high school or junior high school, the force is usually given by mass times acceleration. And in terms of the force being exerted by a stationary object, we could relate this as your mass times g, which of course gives a lot of contribution to the potential energy. But we also have another equation that is related to mass, that's the density. That's mass per unit volume. And of course, if you want to try to like incorporate this density in terms of, or mass in terms of density, so we could just have the force that is equal to density times the volume times the acceleration due to gravity. And in this case, if this is given in terms of the English units, we could just say that the force is equal to 62.4. That's the density of your water in English units, that's pound mass per cubic feet. We multiply this by the volume, which is we do not know yet, and then we multiply this by the acceleration due to gravity, which is of course equal to 32.174 foot. We have foot per second squared, or feet per second squared, divided by 32.174 feet per second squared, multiplied by pound mass per pound force. That's why I told you before that if you have a certain mass, you don't actually have to multiply that to 32.174 because it gets cancelled by the factor. So kaya parang 1 lang yung talagang totoong factor natin when it comes to English units. So we can just cancel this out, and then we'll be left out with pound force. So the force is equal to 62.4 pound force per cubic feet multiplied by the variable volume. So the question here is, what will be our volume? So the volume, of course, we know quite well that if we're considering a circular disk here, kasi sabi dun sa problem, we can consider daw a circular disk at any point here. So, diba, the cone is actually circular in the top view. So, parang ganito siya, no? And remember, we just have to fill this cone somewhere here, 2 feet below the top. So, hanggang dyan lang natin siya i-fill, no? This is just assuming na ito yung ating circular disk of volume. So, from this, if you want to draw a circular disk, just to give a representative volume on our conical vessel, so we could just imagine this circular disk, okay? And diba, pag circular disk, what is the volume of this one? You know quite well that if this is circular, you have an radius, and the area of this circle is pi r squared. But then again, since it's volume, we have to multiply this by the thickness of this disk, and that is actually the change in your height. So that's dh. Well, in terms of these variables in the Cartesian coordinate system, that's simply by x squared, and then you multiply this by your length, I mean the thickness dy, because this is the y-axis and this is the x-axis, so it's like x, and this is your change, the infinitesimal change in y, that's dy. So basically that's your volume. But then again, we could realize that we don't have any volume that is represented by just one variable, because we have x and y. So we have to make sure now we try to incorporate or rewrite x in terms of y, and in this case we can just use the ratio and proportion of a certain triangle that we have generated. So from the figure, you could see there na this one is actually 3 units or 3 feet. This one is 8, diba? But of course, any value here would be x, and this one would be just y. So therefore, we could just say that 3 over 8, that is actually equal to x over y. And therefore, y or x would always be equal to 3/8 over 3/8y. So I use x in terms of y kasi we have dy here. So para hindi tayo magpalit-palit kasi kung y in terms of x, kailangan ko pang hanapin is in terms of dx. So I have to like differentiate pa. So pag ganito, hindi na ako necessary mag-differentiate. So from this, we could just rewrite it. Diba? A would be the lower limit, that's 0, going to the upper limit, that's 2 feet below 6, so that's below 8, so that's 6. So ano ba tong f of x na? So sabi dito, f of x is 62.4 times the volume, and the volume is in terms of this pi x squared dy. So therefore, from this, f would be equal to 62.4 times the variable volume, that is actually equal to pi x squared, so that's 3 over 8y squared, and then we have dy. So therefore, that is your f in terms of y. But ano ba tong dx? Diba usually dx is just a representation of the distance being traveled, parang para magkaroon lang tayo ng change dun sa certain distances na travel. But then again, you could say it from here na meron tayong dy, so hindi nyo na kailangang maglagay pa or isipin ko ano ba tong dx na to. That's just the dy. But there is another missing variable that we have to remember. This is just the volume in terms of the infinitesimal change of y. But this volume kasi, it starts from 0 going to this certain level, and then your dy is just the infinitesimal change. So from this, you could add another value that's y, or another variable that's y, and then that is multiplied to your expression of the volume itself. So from this, we could just say that the final expression would be 62.4 times pi times 3 over 8y squared, and then you multiply this by y dy. Okay, so this y represents the distance from, or the distance of the disk at any point from 0. So kasi kailangan natin siyang incorporate, kasi kung hindi, ang mangyayari lang dyan is like we're trying to determine yung ating volume, yung volume lang nung disk, yun nga, yung volume lang ng disk at a certain distance, let's say between 0 and 6, parang ganun lang siya. So from this, we're trying to determine the volume of all the infinitesimal circular disks that can be drawn or that can be generated from 0 to 0.6. So yun yung concept ng y dito. So you have to remember na when you're dealing with volumes, lagi nyong incorporate yung distance niya from the origin or kung saan man siya magsisimula. That's another thing that you have to remember. Okay, so from this, so hindi ko na ipapakita kung paano ba siya in-integrate. So this is equal to 8,931.862,073. That's in terms of foot or feet-pound force. But remember, we have to determine the value of our work in terms of British thermal units. So we have to divide this by the factor for British thermal units. So that's 1 BTU is equal to 778 point what's the decimal point? 169. So that's 169. So that is 169 foot-pound force. Okay, so we have to divide this by 778.169 foot-pound force or feet-pound force per British thermal unit. Okay, so from this, the value would be equal to 11.4780 British thermal unit. Okay, so I hope na-realize nyo sa inyong handout na mali yung nakalagay dyan na sagot. Okay, so you have to check that or rewrite that kasi I think that's around 32 yung dyan. So you have to change it to 11.4780 British thermal unit. So that's it. You can actually solve this without incorporating ating Cartesian coordinate plane. So halimbawa, ginamit nyo lang is yung R and H. Actually, pwede pa rin yun. You'll be also using the concept of ratio and proportion, and that's just something like R is equal to 38H and something like this, no? So, kung ginamit nyo lang dyan is yung volume, probably, the radius and height, so you might be getting, so like the volume would be equal to pi 3 over 8h squared and then the h. So you'll be getting this kind of formula, and then incorporating this to your work, this will be multiplied to height. So something like that, and then the work would be simply 0 to 6, 62.4 pi 38h squared HTH. So you'll be getting this kind of formula if you would want to use RNH without incorporating it in the Cartesian coordinate plane. So I'm using it kasi pinakamadali siyang magets yung concept niya. And remind you, if you want to use this and then just imagine yung distance nitong you can actually use this parang slant height niya if you want to understand it better. Kasi, diba, this equation is given by y is equal to the slope. So that's just simply the rise over run. So ano ba yung rise nito? So that's 8 units and then over 3. So that's typically 8 over 3x. So x is actually equal to 38y. So, ito rin yung idea nung ating relation proportion ng triangle. So, kapag hindi natin kailangan or hindi natin pwedeng gamitin yung mga ratio and proportion ng triangle, so you might want to use the equation itself na nakaka-generate sa or nag-generate sa ating Cartesian coordinate plane. So, pwede yon yung ganong case. And you'll be seeing that later sa ating iba pang problem solving. But that's the concept of volume or the work that is being generated when you try to fill in a certain vessel. So let's proceed to the next one.